Question 7, consider the equation the tangent of theta equals 5 radical 11 over 11. If theta is an angle in quadrant 3, what is the value of sine of theta? So first off, recall that sine of theta is referring to the coordinate y. So this is helpful because if we look in quadrant number 3 where this angle is, remember quadrant 3, we go counterclockwise, 1, 2, 3. So in quadrant number 3, we know that y is negative. So that means the sine of whatever this angle is also going to be negative. So they give us this for tangent right here. So we need a Pythagorean identity that obviously uses tangent. And we can't use, some people want to use tangent equals sine over cosine, which is true, but we can't use that because we don't know what sine or cosine, either one of those are. But what we do know is we know secant squared of theta is the reciprocal of cosine squared theta. So finding secant squared theta gets us one step closer to finding sine. All right, so let's use this formula, tangent squared theta. So we're going to replace tangent with 5 square root of 11 over 11, and we're going to square it. It's going to equal secant squared of theta minus 1. And then let's solve this for secant squared. So if we square everything in the parentheses here, we get 25 times 11 over 121. Well, I know 11 over 121, that just reduces to 1 over 11. And then we're just left with 25 over 11. So I can get rid of that times 1 altogether. Let me write that 11. A little better. And then let's finish solving this. Next, obviously going to add 1 to both sides. Could use a calculator, but we need to get a common denominator of 11. So we'd rewrite 1 as 11 over 11. 25 over 11 plus 11 over 11 is 36 over 11. Again, use a calculator to speed that process up just a little bit. All right, so we've solved for secant squared. We could take the square root of both sides, but we're not there just yet, taking the square root of both sides, because that's going to complicate matters. So let's continue with the Pythagorean identities. If the secant squared is 36 over 11, that means cosine squared is just the reciprocal of that. So cosine squared of theta is just going to be 11 over 36. I'm going to clear out a little bit of space here because I'm running low on space. But finally, we can use this bottom Pythagorean identity, because remember, our goal is to solve for sine. So cosine squared plus sine squared equals 1. We know cosine squared is 11 over 36. We don't know sine squared. So we're next going to subtract 11 over 36 from both sides. So we're left with sine squared of theta equals 1 minus 11 over 36. We can rewrite 1 as 36 over 36. So we have a common denominator. And then that would equal 25 over 36. And then finally, remember, we don't want sine squared. We don't want sine squared. We want just a regular sine in this problem. So our last step is we're going to take the square root of both sides. Or when you take the square root of both sides, you get a positive and negative answer. Both of these are perfect squares, so this simplifies to 5 over 6. But we said earlier, in quadrant number 3, it has to be negative, because the y coordinate is negative in that quadrant. So negative 5/6. That should be our answer in this problem.